Hello there, Mr. Sutton with these AB Calculus 6-3 Extra Practice Number 1 solutions on slope fields. For this problem, I want the slope field for this differential equation. So let me set up a table going from -2 to 2 on the x and the y-axis. All right, so for x equals -2, we're doing -2 divided by everything for these y values. So -2 over 2 is -1, -2 over 1 is -2. -2 over 0 is undefined, and this whole row here is going to be undefined. -2 over -1 is 2. Then we've got -2 over itself is 1. Moving on to -1 now. -1 over 2, that's -1/2. This will be -1, undefined. -1 over itself is 1. And then we've got +1/2. Now for 0, this is going to give us 0 for everything except 0 over 0. So we've got 0, 0, undefined, 0, and 0. For this next one, we've got 1 over all these numbers, which is essentially just going to be everything in this second column, but with the sign reversed. So +1/2, 1, undefined, -1, -1/2. And finally, +2 is going to give us everything over here, but reversed. So we've got +1, +2, undefined, -2, and -1. All right, graphing those out, we've got -1 there, -2, undefined, 2, 1, and then the next one we've got -1/2. This is -1, undefined, 1, and 1/2. And let's see, we've got 0 all the way down on our y-axis here, except for 0, 0. Over here, this is going to be essentially symmetrical version of everything we have over here. So +1/2, 1, undefined, -1, -1/2. And here we've got 1, 2, undefined, -2, and -1. For this problem, we're graphing the slope field for this differential equation. Let me make a table of all my x and y values between negative and +2. So now for this first one, we've got a y value, actually an x value of -2 that we're subtracting. So we're essentially doing all these y values plus 2. So 2 plus 2 is 4. 1 plus 2, 0 plus 2, -1 plus 2, and -2 plus 2 gives us 0. For this next one, we're essentially adding 1 because we're doing y minus -1. So we got 3, 1 plus 1 is 2, 0 plus 1 is 1, and then you're just starting with a number that's 1 lower each time, so these just keep going down by 1s. Next one, we're just subtracting 0, so we've got 2, 1, 0, -1, and -2. And you've probably seen a pattern here. All of these numbers are going down by 1, so this is 1, and these are all going down by 1. So 0, -1, -2, -3. This goes down by 1 to give us 0, and then -1, -2, -3, and -4. Graphing all these out, we've got a slope of 4 up here, which is pretty steep, and then a slope of 3, which is a little less steep, but still pretty steep. Here's 2, here's 1. Slope of 0 is the easiest one to draw. And next we've got 3, 2, 1, 0, and now -1. Next we have 2, 1, let's see, 0, -1, and -2. And then we've got 1, 0, -1, -2, and -3. Finally, 0, -1, -2 is a little steeper, -3, and steepest of all, -4. On this problem, we want to match one of these differential equations with this slope field. So let me test out some points and see what matches what. So in my slope field, I'm going to look up the point 0, 0. Now, it's kind of hard to see here, but we've got little blue horizontal lines on the x-axis everywhere except for 0, 0. It's actually undefined at 0, 0. So looking at my answer choices, let me keep the one that's undefined and get rid of the ones that aren't. If I plug in 0, 0, choice A still gives me a real number. Same thing with choices C and D. B and D, however, since we're dividing by 0 in those are going to be undefined. So A, C, and D are gone, and our two undefined ones, B and E, are still left over. Next, I'm going to test out 1, 2. So that's a slope of, I'm not really sure, kind of looks like 2. At least it's positive. So I'm going to call that 2, but at the very least it's positive. So plugging in 1, 2 to choices B and E now. For B, we've got, let's see, 2 over 1, which is 2. It's positive. And for choice E, well, that's going to come out negative. So definitely choice E is gone, even if this isn't exactly 2. So that means choice B is our winner. For this problem, I want to match my slope field with one of these differential equations. Let me test a few points to start off with here. And just note as we're doing this that there are little invisible, almost invisible, blue horizontal lines all along the x-axis, including 0, 0. So this is actually defined everywhere that they've shown us. So I'm going to test out 0, 0 to start with. That gives me a slope of 0, reading that off the slope field. And now if we look at our answer choices, which of these give us 0? Well, choice A does. B does as well. C comes out undefined, as does choice D. E gives us 0. So that means choices C and D are gone. Let's keep going. I'm going to test out the point 1, 2 next, up here. This comes out to, it looks like -2, or at least something negative. I'll call it -2 for now, and we'll get more specific if it matters. So plugging 1 and 2 into my remaining choices, let's see, A, that's going to be, let's see, -1 times 2, which comes out to -2. So the A is a good candidate so far. B, this is going to be 1 minus 2, which comes out to -1. And this definitely doesn't look like a slope of -1. If you follow it, that's definitely steeper than 1. And now finally we've got choice E that's still in the running. This would be 2 minus 1, which isn't even negative. So I can eliminate choices B and E off of this. So that leaves me with choice A. For this problem, I want to sketch the solution curve with this slope field and an initial condition of 1, -4. So let me find 1, -4. That's down here. So I'm just going to follow my tangent lines all the way to the edge of the graph. So starting here, let's see, the next one looks like this one, and then this one, and then there isn't really any others that we can follow. So that's about as close as I can get to our solution curve here. For this problem, we want the solution curve for this slope field with an initial condition of -2, 4. Let me find -2, 4 on here. So here's -2, here's 4. So I'm going to start here and follow my tangent lines. So this one appears to go down to here, and it looks like we're going to have to kind of curve back around and go back up. So something like this. For this problem, which we're going to do a few parts in, we have this stem here where they give us this differential equation, and they're telling us x does not equal 0. Y equals f of x is the particular solution to this thing with an initial condition of 1, 2. First part, kind of easy. They just want the slope of the line tangent to the graph of f at the point 1, 2. Well, if you want the slope of a tangent line, you want the derivative. And to do the derivative, you need the derivative formula, which we actually have up here. That's what a differential equation pretty much is. So we just have to plug the point 1, 2 into dy over dx. So doing that, we have 1 minus 2 over 1 squared times y value of 2 minus 1. And you could actually stop here and call it a day because you don't have to simplify your answers. But if you choose to simplify, this is going to be 1 minus 2, which is -1, times +1, so -1 when all is said and done. On this part of the problem, they want us to sketch the slope field for this thing, which is going to be kind of crazy. So let me make a chart, a table first. I need the x values -1, +1, and 2. They don't really care about 0. And you can see why, because if you plug 0 in for x, you're going to get undefined for part of this. We also want the y values going from 0 to 2. So for this first column here, I'm plugging -1 in for x. So let me calculate what that is, and then I'll figure out the rest of it. So if I plug -1 in here, I've got 2 over +1, which is 2. 1 minus 2 is -1. So for this, I'm multiplying -1 times this number minus 1. So -1 times 2 minus 1, that's going to give me -1. And if I'm doing negative 1 times 1 minus 1, that's something times 0, which is 0. Negative 1 times negative 1 essentially is going to give me positive 1. For this next one, because x was being squared, and this is the really good news, because x was being squared, nothing is going to change. Whatever we got by plugging in negative 1 for x, we're also going to get with positive 1. So I'm just going to rewrite everything in that first column. I know it's going to be the same. For this next part, now I've got an x value of 2. So this is going to be, let's see, 2 over 2 squared, that's 1/2. 1 minus a half is also a half. So we're essentially doing 1/2 times y minus 1. So we've got half of 2 minus 1. That's half of 1, which is 1/2. This whole row here is always 0 because you're doing 1 minus 1. And now we've got 1/2 of negative 1, which is negative 1/2. Graphing all those out, we've got negative 1 up here, 0, positive 1. This next column is exactly the same, so negative 1, 0, and positive 1. And now this last one's a little bit different. This last column's different. We've got 1/2, 0, and negative 1/2. For the last part of this problem, of course, they're going to want us to find the particular solution for this differential equation using this initial condition that we haven't really used yet. So first off, do we need to separate the variables? That's always my first question with these. Since I see an output variable, y, in my differential equation, I know that yes, I need to separate these. So I'm going to divide both sides by y minus 1, so dy over y minus 1, or y minus 1 to the negative 1, however you want to write it. And then dx is going to come over to the right side. And to make my life a little bit easier, I'm going to rewrite this term here as minus 2 times x to the negative 2. So I've got 1 minus 2x to the negative 2 dx. Now it's time for some antiderivatives. On the left side, this is going to be ln, absolute value of y minus 1. On the right side, going from left to right, we've got an x minus, and then this bumps up to a negative 1. Dividing by that, we've got plus 2x to the negative 1. So x plus 2x to the negative 1. And then don't forget your plus c, your constant of integration that we now need to solve for. We're going to now plug in the initial value, the initial condition, to figure out what c is. So on the left side, I've got ln of 2 minus 1. And then on the right side, I've got, let's see, 1 plus 2 times 1 to the negative 1 plus c. So on the left side, this is ln of 1, which is 0. On the right side, this is essentially 3 plus c. If I subtract the 3 over to the left, I've got c equals negative 3. I'm about to plug that back in for my c value, but first let me figure out what I'm doing with this ln here with the absolute value. If my initial condition has a y value of 2, that means this y minus 1 stuff inside the absolute value is positive, which means I can just replace the absolute value with a parentheses without negating anything. So I'm going to write ln of just parentheses y minus 1 equals, and now I'm going to have x plus 2x to the negative 1, and then minus that c value of 3. We still have to isolate y. First step in doing that, I'm going to raise e to both sides. So I have y minus 1 equals e to all of this craziness. And then I'm just going to add 1 to the other side, and I am done.